Hello dear friends, myself Mahesh, chemistry tutor. How are you? I welcome you all in today's video lecture. In today's video lecture, we are going to discuss a very important topic of class 12 organic chemistry. Guess what? This is a aldol condensation. Let's start. Aldol condensation. Yes. So first we will discuss that why this reaction is known as condensation reaction. Condensation reaction means, my friend, a reaction in which two different molecules gets coupled with each other, gets linked with each other, but for this coupling, for this joining, small part from each of the molecule should eliminate, and when the elimination takes place, the main substrate molecule gets attached, get binded with each other, and such type of reaction is known as condensation reaction. Okay, understood? I hope so. Now we'll discuss why this reaction is known as aldol. Why we named this reaction as aldol. So let's understand. Because, my friend, when the product of this reaction formed, when the product of this reaction formed at the ending of the reaction, that product contain aldehydic functional group as well as alcoholic functional group. So as it contained aldehydic functional group and alcoholic functional group, we named this product molecule as aldol. Okay, ALD for aldehydic functional group and last OL for alcoholic functional group. So aldol condensation reaction is a type of condensation reaction where the product aldol is formed. Okay. Now we'll see this reaction. What are the different conditions in which the aldol reaction takes place? What is the mechanism? All the important factors we are going to discuss in this lecture. Let's start. Let's see. So my dear friends, for aldol condensation, we required certain conditions that should be obeyed by the aldehyde or ketonic molecule, okay, in order to participate under aldol condensation. So let's see what are those conditions. So the first condition is that whatever the aldehyde or ketonic molecule we have, that must contain alpha hydrogen atom, which is specifically acidic in nature. So it must contain alpha hydrogen atom. Okay. Why we need alpha hydrogen atom? Because alpha hydrogen atom has acidic character by nature. So as it possesses acidic character, that can be easily removed from the aldehyde molecule so that it gets easily converted into the nucleophile. Okay, first point. Now the second point is, the second condition is we must have to provide the alkaline condition for the aldol condensation reaction. So for this purpose we need diluted alkali, okay, like diluted NaOH or KOH or sometimes Na2CO3 we can use. So these are two major and important conditions under which the aldol reaction takes place. Okay. Now we'll see the reaction. So dear friends, the aldehyde molecule which follow these two conditions is acetaldehyde. No doubt other aldehyde also follow, but there are some aldehyde molecule which do not contain alpha hydrogen atom like formaldehyde HCHO and benzaldehyde C6H5CHO. These two type of molecule do not participate under aldol condensation because this molecule don't have alpha hydrogen atom. Okay. Now we'll see the aldol reaction with the help of the acetaldehyde. So here what happened? Acetaldehyde CH3CHO. Okay, and this carbon atom is known as alpha carbon atom, and whatever the number of the hydrogen atoms attached with this alpha carbon atom are the alpha hydrogen atom. So we can write in this manner too: hydrogen, hydrogen, and hydrogen. Okay, friends. So we have three alpha hydrogen atom over here, and when this acetaldehyde molecule is going to react with another acetaldehyde molecule in presence of diluted alkali, that is NaOH or KOH, that should be 10% diluted, my friends. Okay, so the product would be like this. That means the alpha hydrogen atom of one of the molecule gets transferred toward the carbonyl oxygen, and by the help of the linkage we get this type of molecule. This is not the final product, my friends, but this is a aldol molecule. This is a aldol molecule. Aldol means its category name. Okay. Aldol is nothing but the category of this type of molecule. Okay, but its actual IUPAC name or common name we can write. First we'll see IUPAC name. So what could be the IUPAC name of this molecule? Look, we'll start with the help of this carbon atom as it has the higher priority. So 1, 2, 3 and 4. Okay. So third carbon atom has hydroxy group, and the first carbon atom has aldehyde group. So the name is 3-hydroxy, as it contains 4 carbon atom. So butanol. And as you know that the molecule in which the aldehyde group has a priority order, has on the priority order, so such type of molecule is named as alkanal. That means the prefix al is used. Okay, suffix is used. Now we'll see the mechanism of this type of aldol reaction. So dear friend, as the reaction is performed under alkaline condition, okay, so the base will play a important and vital role. That means in the first step of the mechanism, NaOH will provide the basic OH minus ion. Okay, this is not act as a strong nucleophile because the solution is very diluted. Okay, now in the second step, deprotonation of one of the acetaldehyde molecule takes place with the help of this OH minus ion. Now we'll see, this is the alpha hydrogen atom of one of the acetaldehyde molecule, and this OH minus ion will abstract this hydrogen atom, and the two electron of sigma bond between the carbon and hydrogen gets moved toward the alpha carbon atom, and this species gets converted into carbon ion. Okay, this is the carbanion. Okay, my dear friends. Now what will be the next move? The third step is the attack of this carbanion, which act as a nucleophile on the next acetaldehyde molecule in order to carry out the condensation reaction. So this is the next acetaldehyde molecule, my dear friends, and here we have carbanion CH2CHO. Okay, this act as a nucleophile, my dear friends. This act as a nucleophile, and that will attack on this carbonyl carbon. One of the pi bond gets shifted toward the oxygen atom. Okay, you can understand. Now what will happen? This carbon gets linked or bonded with this carbonyl sp2 hybridized carbon atom in this manner. Look, CH3 CO negative H, and here we have CH2 CH. Okay. Now the water molecule that present in the system, that will play the next role, and this oxygen negative charge will abstract the proton from this H2O and regenerate the OH minus ion, and here in the last step the aldol molecule formation takes place, my dear friend. Here we have aldol. Okay, and as I suggest you the name, what could be the name of this molecule? IUPAC name is 3 hydroxy butanol. Okay, now the reaction is not finished yet. Okay, because this aldol molecule further undergo the elimination. Now let's see what could be the next move. The next step is the elimination of H2O from this aldol molecule in order to attain a stable structure, a stable molecule. Now the final step after the formation of aldol is the elimination of water, my friend, in this manner. Okay, CH. So when we heat this aldol product in presence of the acid, okay, in presence of acid, so the elimination of water molecule takes place in this step, and as a result of this one, crotonaldehyde molecule is formed. This molecule is known as crotonaldehyde. Crotonaldehyde. Okay, this is the final product, my friends. Okay, and what is the IUPAC name of this molecule? Yes, guess what? We'll start from this carbon atom 1, 2, 3 and 4. Okay. So the major functional group is CHO and the least priority is going to alkene unit. So what could be the name of this molecule? Yes, but dash 2 in dash 1 dash al. So this would be the IUPAC name. Okay, my friends. Thank you for watching this video. In the next video, we will discuss the Wolff-Kishner reaction and Clemmensen reduction. Thank you.